Okay, it's Mr. Ops here, and we are going to work at composition of functions today. And so what the idea here is for composition of functions is like, here's an example, right? So imagine I have an oil slick in the ocean, and the radius of an oil slick is growing as a function of time, which is shown by this graph here. So time is here, and as time goes on, the oil's radius gets larger and larger. But then I also know that the function of the area is a function of radius. So as the radius increases, the area also increases. And so I know that area is a function of radius, which is a function of time, or A of R of t is how it works out. Now, so if I come along here and I'm going to do A of R of 4, well, this 4 is actually the same as the t here. And so if I go to my graph here, I can see when it's 4, it is going to be 1.5. So the radius is 1.5. So I can tell that this value R at 4 is 1.5. And so then I move to this graph here and I go 1.5, my radius is going to be 7 for my area. And so I use my values and I read the graphs and I can evaluate this. B part is actually asking for A of R of 2. Well, if I use my graphs again here, let me just clean this up a little bit. So if I use my graphs, if I do have 2 here produces a 1. So this means A of 1. Then I go to my here, and I can see here, if I can estimate that, is probably going to be about approximately 3. And so we, basically what happens is we go from variable to variable to variable. And if I know time, I can find the area. Here's another example that we can look at. So we can measure the swimmer's speed as a function of time, so S of t. And then we could measure the swimmer's oxygen consumption as a function of her speed. So consumption and speed. Thus combining them, we would have the oxygen consumption as a measure of time. And so C is a measure of S is a measure of t, which is C of S of t. So if we consider this scenario here, C of S of t is the same thing as saying C of S of 40. S of 40, using our time here, 40 produces a speed of 2. So that's C of 2 because this is equal to 2. Using my speed, I can go speed and over here, and I can see that my oxygen level is 15 liters per minute. And so we can, if we know time, we can find the oxygen consumption. They are related. And so if we put this together, what happens if I start off with some time? The time I can do, if F happens, I can do F at t. And then if G happens next, then I can do G of F of t. Or G of F of t. We can do one whole function here, or we can do it into parts as we go. And there's the concept behind composition of functions.